So when we have a parabola, that's like the San Francisco Bridge. It's called Golden Gate. Okay, and we've seen this all the time, the cable that curves down. This is different than that hanging chain because there's actually some weight being held up. So when the chain is hanging independently, it's called a catenary. That's this. When the chain is pulling up weight, which is what happens on the Golden Gate Bridge, this is a parabola. Now the mathematics to show you is a little complicated. It's involving derivatives. I'm not going to go there with y'all. Just wanted to point out the differences and a little bit of the history. So we're going to have an example problem. We're going to begin with some information about a bridge, and we're going to set up the equation and then use it to determine another point on the curve for the parabola of the Golden Gate Bridge. Okay, and so that would be this problem. All right, so we again, as I've just pointed out, we know this is a parabola. So what information we're given here is the two towers extend 200 feet. That means up in the air. And the distance between the two towers is 500 feet apart. Okay, and then we want to get the equation from that information and then use it to determine how tall is a point on the cable 50 feet away from the center. Okay, well, the distance between the two cables is 500, and these travel 200 feet high. So that's pretty straightforward. But if we're going to solve this problem, then we want to figure out how to set up the parabola equation. Well, we might as well use vertex form. Okay? And if we're going to be able to pick what number we use for the vertex, which would be right here, we might as well pick the easiest pair of numbers ever. So we're going to choose to make this the origin, because then these are both 0. A lot easier. Okay, so then we can just use this as our model. Yeah, much more convenient. Now, if we're going to find out the value of a for this thing, we're going to have to replace the x and y with a known point on the parabola and solve for a. We've already determined that this would be the vertex at the origin for convenience. Well, if that's in the middle, that means half of 500 would go to the right and half of 500 would go to the left. All right, so if we're going to, actually, it's right here, 200 from that point. Okay, so over here would go up from the origin 200 and over from the origin 250. All right, so again, I exaggerated these lines here to make a point, but this is where we're starting from to go up 200, not here. Okay, so now we have an xy we can use. 250 to the x, 200 to the y, so we go over here. Okay, and now I'm going to show you a little mental math because we're not going to get our calculator. I'm going to go ahead and just divide this to get what a equals, and then I'll show you some ways to deal with this. I'm going to write that as 25 times 10.
Wait, Mr. Napoli, where'd you get the 250 from for the x?
Since we knew the distance between the towers is 500, if the vertex is in the middle, that means half of the 500 goes to the right,
okay.
And half of the 500 goes to the left. Yeah, always ask. Yeah, always ask. You know, sometimes I need a little help too. So now I'm just showing y'all how to do some mental math with this. If you're not worried about that, then, you know, calculator, but we want to deal with fractions, right? I'm splitting this up. So that means 25 squared and 10 squared. Ooh, 10 squared is 100. 200 divided by 100. Ooh, really cool. All right, so then that's going to become 2 over 25 squared. And, you know, I'm going to leave it this way, but that's 625. So now you have a fraction. 2 divided by 625, you didn't convert to a decimal. I'm just going to leave this as 25 squared, though. All right, so now we have our problem. A equals 2 over 25 squared, x squared. All right, now that we have a model for the parabola, here's our model. We found the a value. We made the vertex 0, 0 so that we had an easier vertex form. What's the height at a point on the parabola 50 feet to the right of the vertex? So that means when x is 50, what's y? So that means we put 50 here. Notice why I left it as 25 squared. 50, 25. All right. Okay, now both of those numbers are squared. So we can kind of do a reverse exponential property thing. I'm going to put the 2 and the 1 here, 50 squared and 25 squared there. So now I'm just going to go ahead and change it to the square of the whole fraction. Oh, look at that. That's actually 2 squared. So 2 times 2 squared is 8. Now you can impress your friends. Right?
Where did the 50 come from?
The point that was 50 feet to the right of the vertex, how tall would that be? So from the origin,
okay.
when you go 50, that means x is 50. Now, admittedly, I picked friendly numbers so I could show you these numerical tricks, right? But even if you didn't do this way, make sure you don't always change things to a decimal, because then you're going to have to estimate this. And then that's going to give you a little bit off. So you might get 7.9 or 8.01, or actually 8.1, which, you know, engineering-wise, that might matter. You know, if you're off by 2 inches, you know, in carpentry, that's big. Imagine if you're off by 2 inches on the frame of your door, right? So depends on the sensitivity of the application, whether that's a big deal or not.